I wanted to give you some help on this homework problem number 19, this word problem. And whenever you're asked to write a function that represents exponential growth, which is the case in this problem, or exponential decay, which you will do in other problems, let me just give you a general method to go about that works for either, and then we'll work on this problem specifically. So first of all, as you saw in our examples of graphing, you can think of exponential growth in equation form like this. Y equals A times B raised to the X power. Okay, so if you're ever asked to write exponential growth or decay, you can basically start here. Okay, so let's talk about what these letters represent. A is what we call the initial value. Okay, so let's just go to this problem and see if we can figure out what that number is that's called the initial value in this particular case. So we're told a virus spreads through a network of computers such that each minute 25% more computers are infected. Okay, if the virus began at only one computer, so that tells me that my initial value is just going to be 1. Now we typically don't write coefficient 1, but for purposes of illustration, I'm just going to go ahead and write it. So you can see that my initial value in this problem is 1. Okay, so another thing that we know is this letter B in growth problems, which is what we have here because we're told that the virus is spreading. It's spreading by 25% at a 25% rate. So in this case, B is called a growth factor. And if this were a decay where maybe something is losing at a 25%, maybe a value is being lost, maybe like a car loses value over time, then it would be called a decay factor. Okay, for growth factors or decay factors, in both cases you start with 1. So let me just go ahead and cover both. To get B, you will always start with the number 1, and then if you do have growth in your problem, you'll just add whatever the percent of growth is in decimal form. Okay, so it's going to be just based on your problem. Look at what the percent rate of growth is, change that to a decimal, and then add 1 to it. So in going back to our problem here, B is going to be 1.25 raised to the X power. Okay, so basically I just took 25%, changed it to decimal, and added those together. So let's just go ahead and talk about if this were a decay problem. For a decay problem, I know this isn't, but you'll come across these. The only difference is going to be how you find B. Well then for B, it's called a decay factor, as you could probably guess. And you could probably also guess that instead of adding the rate of growth, we're going to subtract the rate of decay. So if I turn this around, maybe we pretend like the value of a certain asset is decreasing by 25% over a certain period of time. Then I would start with the number 1, always start with 1, but this time I would be subtracting 25%, and my B number would be 0.75. Okay, so just want you to see that for future reference. This is what we're obviously working with here. So X, we have one more variable to identify. X is always a time period. And you'll just have to read your problem to know whether they're talking about minutes, hours, years, and in this particular case, we want to know for the first hour of the spread of the virus. Okay. Well, if you read the problem, yes, we are wanting to know a function that will tell us the spread of the virus for the first hour, but the rate of the spread is that it's per minute. Notice that first phrase, a virus is spreading such that each minute 25% more computers are infected. So in this particular case, X is going to be a number of minutes. All right, and so my equation to find the spread of the virus would be this. If I make sure that I identify X as a number of minutes, and I'm just going to go ahead and let you take your calculator. If you want to know the exact number of the spread after the first hour, then obviously you don't have to multiply by 1, but there is a 1 there. So you're going to be doing 1.25. And since we want to know the first hour, convert this into minutes. And so you would raise that to the 60th power. Okay, so the function that would tell us, it says write and graph. I'm not going to ask you to graph it, but I do want you to write this function and then use your calculator to just come up with that actual number and bring that to class with you. But I just wanted to give you an overview. Anytime you see these word problems where you're asked to write a function that represents exponential growth or decay, now you're going to be ready for either one. And hope that helps you. And if you have any questions, let me know.